actually moves this to section 3.3, by the way, the biconditional statements. So again, all these rules, there's just a bunch of rules actually that you just need to read, and you can click on your Math Excel homework assignment. Any homework assignment has a textbook link. Lets you go into the textbook, read the pages, and just page over till you feel like you've read all the rules. Copy those down until you get those straight, and it will help you do your homework. But the book will tell you this statement, this is called a biconditional, and it is only true when P and Q have the same truth value. All right, now this is a little different than our and or statements. The or, either one could be true and it was true, and then the and, they had to both be true to be true. Okay, that was our old rule. For this rule, the biconditional, it says they just have to have both have to have the same value. So if they're both true, that's going to be true, or if they're both false. Two false make a true. So that's just the rule. And so you can read up on that again. But the biconditional statement, they just have to have the same truth value, or the same validity. All right, if it's just one arrow, a conditional, the rule is it's true in every case except whenever P is true and Q is false. If you have a true to a false, then that is a false. Every other case will be true. All right, so let's go through this problem now. So we're given a truth table. It starts out with a P and Q. And again, for P and Q, there's four possibilities, both true, true and false, false and true, false and false. The four possibilities for two statements. All right, then it says to do not Q. The next column is not Q, which just means write the opposite of column Q, F, T, F, T. Then it says do that with an and P. Now we can't do the and part until we get this column filled in. So you have to jump over here, do column P, and then do the and statement, the connective. So column P, just copying what we have here. And then the and part, remember and means they have to both be true. So we're judging between not Q and P, these two columns. So that's false. These are both true, so that's true. That's false, and that's false. So just this one was true. All right, then we go on to do the biconditional statement, which again, we cannot do that operation until we have what's over here. So the last column is not P. So we're going to do the answer to this, and this is in parentheses in your Math Excel problem. And we're going to have that with not P. Not P just means do the opposite of P. So false, false, true, true. And then do the biconditional between that. Now remember, this is our new one. Biconditional means they just have to both be the same, either both false or both true to get a true. So we're judging between the answer to what we got in parentheses. That answer was this column. So focus on this column, and the not P. If they're both the same, two false makes a true. Those are different, so that's false, different, false, different, false. So that's the only final truth in this problem. But I don't think it asks you to analyze it further, just fill in the table. Okay, two more problems in logic. Number 11. And to do 11 and 12, this comes from section 3.5, talking about valid arguments, so kind of the last of what we do in chapter 3. And so there are four types of logic that you need to understand. Valid arguments. So if you read up in section 3.5, you'll find there is the law of detachment. If P, then Q. So if Q happens, then Q happens. That's called the law of detachment. I'll write this down for you. And that's how we'll determine the answers to number 11 and 12. So valid arguments. The law of detachment says if you have an if P then Q and P happens, then you can judge that therefore there will be Q. If P then Q, P happens, therefore Q happens. That's a valid argument, the law of detachment. Okay, the second law of contrapositives. says if P, then Q. So if not Q, therefore there was not P. That's a valid argument. The third valid argument is the law of syllogism. It says if P, then Q. If Q, then R. And I kind of think of this as being a transitive property. If P, then Q. So Q happened, and that led to R. Then P must also lead to R. That's the law of syllogism. The fourth valid argument that we study, disjunctive syllogism. It says P or Q. You know, the or statement means either one of those can happen. I should have drawn my line yet. P or Q. So if there was not Q, then it must have been P. Therefore, P. Or vice versa. If not P, then therefore it must have been Q. All right, so looking at these statements on number 11, we want to see if we can find one of these laws kind of in the order of the statement. So number 11 says a biconditional, so it means P, if and only if R, so you're assuming both happen or both are the same. So if R, then Q, therefore if not Q, then it couldn't have been P either. So you think through this, it's saying if and only if. That's what the biconditional says. It means these have to be exactly the same, either both false or both true. So whenever you have the double arrows, these are the same values. So if we had R leads to Q, then if you didn't have Q, you couldn't have had P because those had to be the same. So we can say that is an argument that is valid. Number 12 follows along exactly with one of these laws of syllogism, though, that you can see this. It says, if it rains, then I won't go to the beach. So that's an if P, then Q statement. Let's say that's if it rains, so if P, then I won't go to the beach. The negation of that statement, so we'll say not Q. Then it says if I don't go to the beach, so that's not Q, then I'll be upset. So that's a new statement, by the way. So if not Q, then I'll be upset. We'll call that statement R. So we can then say P leads to R. That was that actual, I think I've erased it, argument number 2, kind of the transitive part property. So it says, therefore, if it rains, then I'll be upset. Okay, so that went from if it rains, then I'll be upset, which bypasses that thing that happened in between, kind of the transitive property, and that would be a valid argument.